Bismillahirrahmanirrahim. Welcome to subtopic 9.1.1 Basic Hardware. The program must be brought from an input device into main memory and placed within a process for it to be run. Since main memory and register the only storage that CPU can access directly, that's why we need to put a process into main memory. The main memory unit only sees a stream of address and read requests or address plus data and write requests. Okay, since register is built in CPU core, the access of register is done in one CPU clock or maybe less, while main memory, it can take many cycles, thus causing a memory stall. So remember, we already learned about memory stall in subtopic 5.5.2. So this situation is intolerable. So the remedy is we add a fast memory between main memory and CPU registers, which is known as a cache. Okay, so you already learned about cache in computer organization and architecture. Right, so we don't only care or concern about the speed to access the physical memory. We also need to ensure correct operation by protect the memory space. Okay, actually there are several approach that we can apply to protect our memory. Okay, in this video we discuss one of the approach. Okay, right. So okay. We in this approach that we are going to discuss, we only allow a process, okay, to access only those address in address space. We are not allow process to access operating system or to access any other process. Yeah. So we can doing this by pair of base and limit register. The base register is the starting address. The base register is the starting address of the region of memory, while limit register is the size of the region. Okay, either in bytes of or words. It also known as this combination is also known as bound register. Okay. So in this example, let's say our base register is at the address of 300,040. Okay, and the limit register, the size of the region is 120,000. Okay, thus the boundary register is 420,939. Yeah. So meaning that if the program want to access this process, it's only allowed to access between these two address. Okay, so CPU hardware to implement the protection. Okay, CPU will must check every memory access generated in user mode, okay, to be sure it is between base and base plus limit register. Okay, so meaning that CPU will compare the address generated in user mode. Okay, is it is it more or equal with base register? If yes, it will continue with the next process. If no, meaning that the address is less than base register, it will treat the address as a fatal error. So if yes, okay, it will make next comparison. Is it the address that generated in user mode? Is it less than base plus limit register? Okay, if yes, it allow the user program to access the memory. If no, meaning that if the address is more than base and limit register, it will treat it as a fatal error. So the instruction to loading the base and limit register are privileged in kernel mode, since only the operating system execute in kernel mode. So only the operating system can load the base and limit register. Okay, so this scheme allow the operating system to change the value of the register, but prevent user programs from changing the register content. Okay? That's all in this for this subtopic. Thank you for watching, guys.